Hey, year 10. So I've been looking at quadratics for a little bit now, but one of the things that I find is that a lot of people find it a little bit difficult to kind of fit all the things we do within quadratics together. So before I look at 7C and sketching parabolas using factorization, I just want to give you a little bit of an outline about how things sort of work. So what I've got written in blue here are three different ways we can kind of view a um, quadratic function. So this form here is an expanded form. So I've got our a, b, and our c. We should be reasonably familiar with this sort of thing. But there's two other ways we can actually see them. So there's turning point form as well, which again we looked at. And the way that we get from expanded form to turning point form is by completing the square, which is again something else that we've done before. Now, we can also have factorized form. Now, we've factorized quadratics before, but what we can do to get from turning point form to factorized form is factorize using difference of two squares, again, which we looked at a few lessons ago. But you can also go from your expanded form to your factorized form just by simply factorizing. Okay, so we've actually done all these things. We've done that before, we've done that before, we've done that before. And we have actually dealt with all of these forms of a quadratic function. You might be like, why do we have these three different things? What's good about them? Why do we have to change between them? The reason we change between them is they all offer us different things that we can find out about quadratic functions. So they all have their own strengths. So if I look at this one up here, the expanded form, c, which is the letter at the end, that's the y-intercept. So if you've been given this form, you don't need to do any working out to find the y-intercept. That is it. Okay. Also, if we go down to turning point form, the strength of this one is it tells us what the turning point is. So the numbers in here, in h and in k, they tell us what the turning point is. And down here, if we look down at our factorized form, the strength of that is the factors can be solved to find the x-intercepts. So these are the three really important things you need to find when it comes to sketching parabolas. So you need the y-intercept, you need the x-intercepts, and you need the turning point as well. So all of these different forms, if you can change between them, you're going to be in a very good position in terms of knowing how quadratics works and doing really well with it. I've found that those who can get on top of quadratics nice and early, they end up doing really, really well in year 11 and 12 as well. So if you manage to have a good understanding of this sort of stuff, you're putting yourself in a really good position. All right, now let's go to the next little section that I've got here. Now, the other day, some people were finding it hard to locate where the turning point was. Now, hopefully we remember that the turning point is on the axis of symmetry. So I might just do a little drawing up here. If we have our parabola, let's just say it goes like that. The turning point's here. The axis of symmetry is this little vertical line that goes down there. Okay, so it's actually the x value of the turning point. Now there's a formula that we can use to find that x value, which is this here. It's called the axis of symmetry formula. Now this b and this a, it comes from this expanded form up here. So there's b and there's a. So you'd substitute those values in, and then it's giving you the x value of the turning point. But we need the y value as well. So what we then do, as I've got written here, is find the y value that goes with the x value to show the turning point. So you'd be substituting the x value into the rule. That's not the only way you can find the turning point. Obviously there's turning point form, but another thing which you're going to be using today is this here. So the turning point is always halfway between the x-intercepts. So if you know where the x-intercepts are, you're going to be able to find out where the turning point is as well. So that's the key thing that we're going to be working on today. So let's start on these few examples. There's 4 of them, so it might take a little bit of time, but I just want to make sure we're really clear about it. All right, so we want to find all the key points in order to be able to sketch the graphs. Let me find my pen. Okay. So we need y-intercept, we need turning point, and we need x-intercepts. I'm going to start with x-intercepts here. Now to find the x-intercepts, we need to make y equals 0. But factorizing is also going to help us too. Okay, so actually I might factorize first and then I'll make y equals 0. Alright, so if I look at this here, I can see that x is common to both sides, so I can take x out as a factor, and that gives me x minus 4. So if that's expanded, it's going to give me the same as what's up there. Now, using null factor law, by making y equals 0, we can find the x-intercepts. So finding x-int, make y equals 0. So 0 equals x, and x minus 4. Now hopefully remember solving these. We have one part that says x equals 0, and we have another part that says x minus 4 is equal to 0. So our solutions are going to be x equals 0 and x equals 4. So these are our x-intercepts. So one of them where x is 0, y is 0, and where x is 4, y is 0. Alright, now that we've got those two x-intercepts, and we know that the turning point's halfway between them, if you've got an x-intercept at 0 and 4, what's halfway between 0 and 4? The turning point must be at 2. Alright, now we can use x equals 2 in our rule to find out what the y value is that goes with it. So what I might do is take our rule, except instead of x, I'm writing in 2. And that's going to give me my y value. So the y value is going to be 4 minus 8. So our y value is negative 4. So therefore, our turning point is where x is 2, y is negative 4. The last thing we need to find is our y-intercept. Okay, so to find a y-intercept, you make x equals 0. There we go. Okay, so let's take our rule, make x equals 0. We can see our y-intercept is at 0. So therefore, where x is 0, y is 0. Now I'll just really quickly sketch the graph. What I'd like to do is put all the points in and then work out where the line goes. So if we've got a y-intercept at 0, 0, that's here. I'm going to show the coordinates. I've got an x-intercept at 0, 0, already shown it, and a y-intercept at 4, which is here. So that's at 4 and 0. We worked out that the turning point was at 2 and negative 4, so 2 would be here, negative 4 can be down here. There we go. And this is a smiley shaped parabola because out the front here, which I'm going to keep reminding you, out the front here, if your a value is positive, it's going to be a smiley face. If it's negative, it's going to be a frowny face or a sad face. So there we go. We found those 3 things that we needed. I might make some more space for this one. Okay, next example. So we want to find those 3 important things. We want y-intercept, x-intercepts, and turning point. So let's just do our y-intercept over here. Now you could make x equals 0, which will work to find the y-intercept of any graph, but we can already see that the y-intercept is going to be here because we've been given that expanded form. So our y-intercept is at where x is 0, y is 8. Don't need to do any working out. The next thing we want are our x-intercepts. Okay, now to find our x-intercepts, we need to factorize and then make y equals 0. So let's factorize first. So we'll start with our rule. We want to factorize. So the factors of a times c, so the factors of 8 that add to make minus 6. Minus 2 times minus 4 gives us 8. Minus 2 plus minus 4 is minus 6. So that's what we want. And we can put this straight into factors. So x minus 2, x minus 4. We've factorized. Now to find the x-intercept, make y equals 0. So if we have x minus 2 equals 0, x will be 2. And if we have x minus 4 equals 0, x will be 4. So we've got our two x-intercepts just here. So x is 2, y is 0, x is 4, y is 0. The last thing we need is the turning point. Now, the thing that we're supposed to be looking at today is that the turning point is always halfway between the x-intercepts. So halfway between 2 and 4 is 3. So we know that x is 3 for our turning point. So if we kind of started off, our x value is 3, but we don't know our y value. We do have a rule though. So if we put our x value into our rule, it tells us the y value we want. So let's do it. If x is 3, let's see what it gives us. So we've got 9 minus 18 plus 8. So y, it looks like it is minus 1. Yep, minus 1. So therefore, where x is 3, y is minus 1. And that's the turning point. Here's all the info we need. So let's just start connecting those dots. Now it's okay if it's not completely perfect. Alright, our y-intercept is up here at 8. 0 and 8. Our x-intercepts are at 2 and 4. So 2 can be there, and 4 can be here. It's not perfectly to scale, don't worry too much about it. And there we go. We've got our x-intercepts. The last thing we need is our turning point. So 3 would be there, minus 1 might be here. So our turning point is at 3 and minus 1. Now we're just connecting the dots. And we're done. There's that one. Right, next example has, you'll see that there's a 2 out the front. You see how we've got 2x squared when there'd normally just been x squared. Hopefully when you look at this whole thing, you can see that there's something common to all of it. And it's 2. See how it's 2 out there? There can be a 2 in here and 2 here as well. So we can actually take that 2 out as a factor. So before we do that, actually, let's just look at the y-intercept, because we are really just trying to graph here. If we make x equals 0, that'll end up being 0. That'll end up being 0 plus 6. So our y-intercept is 6, which is the c value over here. So where x is 0, y is 6. We've got our first key point. Let's look for our x-intercepts now. So to find the x-intercept, we factorize and then make y equals 0. So if we take that 2 out as a factor, that's going to give us 2. We take it out, x squared plus 4x plus 3. There we go. Alright, now we've taken that as a factor. Let's try to factorize what's going on in here now. Okay, so the 2 is going to stay at the front, but we don't need to worry too much about it. We want the factors of a times c that add to make b. So 1 times 3 is 3. Factors of 3 that add to make 4. 3 times 1. That gives us 3, but 3 plus 1 gives us 4. So x plus 1, x plus 3, we're factorized. All we need to do now is make y equals 0 to find out x-intercepts. So make y equals 0. Now with this here, you don't need to worry about the 2. We're making both of these things here equal 0. So if we have x plus 1 equals 0, that gives us x equals minus 1. And if we have x plus 3 equals 0, that gives us x equals minus 3. So they are our two x-intercepts. X is minus 1, y is 0, x is minus 3, y is 0. Last thing we need is the turning point. Now again, what we're learning today, turning point is halfway between the x-intercepts. So halfway between -1 and -3 is -2. But I need the other part of the coordinates. So I know that x is -2, but I want to know what the y value is. So to find the y value, let's use our rule. If x is -2, y will be, let's see, okay, so we've substituted that -2 in there. So that's going to give us 4 times 2 is 8, minus 16 plus 6. Okay, so it looks like it's 8 minus 16 is minus 8 plus 6 minus 2. So -2 and -2. Cool, so let's sketch it now. And again, we're just putting those dots in and we're just connecting them. Alright, so y-intercept is at 6. Let's say that's here. X-intercepts are at -3 and -1. Say -1 can be here, -3 can be here. Here we go, turning point at -2, -2. So -2 is there, can be here as well. -2, -2. We've got all our dots. Let's connect them. That's a pretty dodgy sort of shape, but that's okay. You can see the picture. There we go. Alright, now the last sort of thing that we're going to look at is that perfect squares have their turning point on the x-axis. So you might remember back to perfect squares. A perfect square is, and we'll use this one as an example. If you look at this middle term and you half and then square it, it should give you what's here if it's a perfect square. So if you half that, it gives us -5, and then square it, gives us 25. Therefore, this is a perfect square. These ones have their turning points on the x-axis. Okay, on the x-axis. So let's just look at our other things. So let's look at our other key points. So let's find our y-intercept. It's always this bit here. So x is 0, y is 25. And now we want our x-intercepts. Okay, now what we can do is factorize and then make y equals 0. That's how you find your x-intercept. So if we factorize this, if you remember about perfect squares, it's going to give us x minus 5 squared. If you're not sure how I did that, maybe go have a look at our completing the square or perfect squares video. Now we want to make y equals 0. Okay, so that means we've got x minus 5 equals 0, so x equals 5. That's where our x-intercept is. There's only one of them because you see how it's squared there. That means you got the same thing twice, so x equals 5 and x equals 5. Alright, now what you might notice with this here is that it's sort of in turning point form anyway. There's like a +0 here. So what that means is the turning point is going to be at 5 and 0. Okay, now let's connect all these points. Alright, y-intercept's at 25. This isn't going to be perfectly to scale, don't worry about it. Our x-intercept is at 5. And our turning point is at that same point because it's on the x-axis. Okay, the turning point is on the x-intercept. So what we're going to have is this sort of thing here. And we're done. So what we need to know is that when there's a perfect square, their turning point is on the x-axis. So their turning point and x-intercept are on the exact same spot. Okay, so for perfect squares, the turning point is equal to the x-intercept.